Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Douglas Engelbart's definitive 1962 monograph, formerly titled Augmenting Human Intellect, a Conceptual Framework, stands as a singular testament to programmatic vision in the history of technology. Its pages articulate a comprehensive philosophy for the co-evolution of humanity and its tools, a vision so foundational that its propositions continue to animate contemporary discourse. The enduring relevance of this work derives from the rigorous internal logic of its conceptual architecture. This essay undertakes a direct and systematic evaluation of the framework's principal claims, proceeding section by section through Engelbart's original argument. The purpose is to analyze the coherence, depth, and implications of the specific mechanisms he proposed, examining the intellectual edifice he constructed as a self-contained system of thought. We begin by assessing his formulation of the core problem, moving sequentially through his proposed systemic solution, his concrete example of an augmented process, and his strategic plan for achieving this profound transformation in human capability. The analysis will illuminate the work's power as a generative set of hypotheses, a blueprint whose claims function less as empirical findings and more as the essential axioms for a new field of human endeavour. Section 1. The introduction's framing of the problem. Engelbart's opening section establishes the foundational premise for his entire project. The world's complex, urgent problems are increasing in scale at a rate that outpaces humanity's innate problem-solving capabilities. His central claim here is one of civilizational urgency. He posits a direct correlation between the rate of technological and social change and the cognitive burden placed upon individuals and institutions responsible for navigating this change. The evaluation of this claim reveals its power as a rhetorical and logical starting point. Engelbart refrains from a simple lament, instead framing the situation as an engineering challenge. The core argument is that human intellect, viewed as a functional capacity, has reached a plateau defined by its biological and unaided cultural inheritance. To surmount this plateau, a deliberate, systematic effort to augment this intellect is required. He presents this as an imperative for survival and progress, lending his subsequent technical proposals an almost ethical weight. The internal coherence of this section rests on its successful portrayal of a capability gap. He argues that professionals, scientists, leaders, and citizens are attempting to grapple with multidimensional, interconnected issues using cognitive tools that evolved for a simpler world. His diagnosis is compelling because it avoids blaming human failing and instead identifies a mismatch between the complexity of the environment and the capacity of the unaugmented problem solver. The claim's strength is its universality. It applies to any field of complex human effort, from scientific research to governance. This framing effectively creates the intellectual space and the sense of necessity for the radical intervention he is about to propose. He is defining a new category of problem, a problem of improving the means by which we solve all other problems. Section 2. The H-LAMP system as a conceptual model. The second section of the framework introduces its central theoretical construct, the H-LAMP system. This acronym, representing the human using language, artifacts, and methodology in which he is trained, serves as the cornerstone of Engelbart's entire intellectual edifice. The critical claim embedded in this model is that human intellectual effectiveness is an emergent property of an integrated system, where each component is inextricably linked to the others. Evaluating this claim requires a granular look at each element. The H for human represents the organism's basic sensory, perceptual, and cognitive faculties. L for language encompasses the entire symbolic toolkit, from natural language to mathematical notation, which shapes how concepts are formed and manipulated. A for artifacts includes all physical and conceptual objects that aid the process, from a pencil and paper to a library's classification system. M from methodology covers the explicit procedures, strategies, and heuristics used to organize work. Finally, T for training represents the conditioning that enables the human to proficiently wield the other components. The genius of the H-LAMP model lies in its assertion of systemic indivisibility. Engelbart argues that one cannot meaningfully improve one component in isolation. A new artifact, such as a computer, is of limited use without a corresponding evolution in the language to describe its operations, the methodologies for its use, and the training to build proficiency. This claim is a profound departure from a tool-centric view of technology. The system itself, the complete H-LAMP complex, is the proper unit of analysis and the target for improvement. Evaluating this claim today, one sees its predictive power. The failure of many technological interventions can be traced to a neglect of the linguistic, methodological, or training dimensions Engelbart identified. His framework provides a powerful diagnostic lens. The model's internal logic is robust, presenting a holistic and dynamic view of intellectual work. It is less a descriptive model of a static reality and more a prescriptive one for how to conceptualize and engineer progress. Section 3. The principle of bootstrapping and coevolution flowing directly from the systemic logic of the H-LAMP model, Engelbart introduces what is arguably his most powerful and original claim, the principle of bootstrapping. He posits that any improvement to the augmentation system can be used to accelerate the process of making further improvements. This creates a recursive, positive feedback loop, enabling an ever-accelerating rate of growth in intellectual capability. The evaluation of this claim reveals it as the engine of his entire vision. Bootstrapping transforms the project from one of simple tool-building into a strategy for meta-level improvement. The core argument is that by augmenting the intellect of the researchers and designers who are themselves building augmentation tools, their own effectiveness is amplified. The improved team can then devise even better tools, languages, and methodologies, which in turn further augment their own capabilities, and so on. This concept of recursive self-improvement is the theoretical mechanism for achieving the exponential growth in capability needed to meet the challenge outlined in the introduction. The claim's validity rests on the tight coupling of the H-LAMP system. If the system is truly integrated, then an improvement in one part, such as a powerful new symbol manipulation artifact, will necessarily create the potential for developing more sophisticated methodologies and conceptual languages. A team, by using the very tools they are creating, co-evolves with its technology. He theorizes that this process will lead to new modes of thought and collaboration that are qualitatively different from what came before. This is a claim of profound significance, suggesting that our cognitive limits are a function of our tools, and that by improving our tools in this recursive manner, we can fundamentally reshape the landscape of thought itself. The bootstrapping principle is the strategic heart of the framework, providing a plausible, albeit highly ambitious, pathway from the present state to the augmented future he envisions. Section 4. The architectural example of hierarchical structuring in the third section of his framework. Engelbart moves from abstract theory to a concrete, illustrative example. He presents a hypothetical knowledge worker, an architect, using an augmented system to manage a complex project. The central claim of this section is that the dynamic, hierarchical structuring of information is a cornerstone of augmented intellectual work. This example serves as a proof of concept for the H-LAMP and bootstrapping principles. The evaluation of this section must focus on the coherence and power of the specific mechanisms he describes. He details a system where textual and graphical information is organized into a flexible hierarchy. The user can view the information at any level of detail, from a high-level outline to the most granular statements. He introduces symbolic addressing, where statements are labeled with coordinates, for instance, Statement 1, Statement 1 alpha, Statement 1 alpha 1, allowing for precise reference and manipulation. This is complemented by the ability to jump instantaneously between related concepts via explicit links, a clear precursor to hypertext. The claim here is that such a system fundamentally changes the process of composition, analysis, and comprehension. The user is freed from the cognitive overhead of managing a linear document able to rearrange ideas, explore connections, and study the logical structure of an argument with unprecedented fluidity. The power of the example lies in its specificity. Engelbart meticulously describes commands for deleting a subhierarchy, moving a statement, or creating a new view that shows only statements with a particular keyword. In doing so, he makes the abstract concept of augmentation tangible. He is demonstrating a new language and a new methodology, enabled by a new artifact. The architect in his example is thinking differently because the tools permit and encourage a form of thought based on structured exploration rather than linear exposition. This section's claim is validated by its internal consistency and its persuasive depiction of a qualitatively superior working process. It provides the crucial evidence, albeit hypothetical, that the abstract framework can translate into real, transformative capability. Section 5. The detailed symbol manipulation capabilities further within his illustrative example. Engelbart details a set of symbol manipulation capabilities that form a bedrock of the augmented system's functionality. The claim here is that the ability to control the presentation and structure of symbolic information with speed and flexibility is a primary means of augmentation. He moves beyond simple word processing to envision a deep, semantic control over the user's conceptual space. Evaluating this claim requires examining the specific functions he proposes. He describes sequence control, allowing the user to display statements in various orders without altering the source file. He outlines content filtering, enabling the user to generate custom views based on keywords or other metadata, for example, showing only statements written by a certain author or before a certain date. This is a primitive yet powerful form of database query applied to the user's personal knowledge base. Furthermore, he describes the manipulation of the text itself, proposing single-character editing, word translocation, and even more complex structural editing with a pointing device, the device he would later help actualize as the computer mouse. The coherence of this set of claims is remarkable. Engelbart is effectively specifying the functional requirements for an interactive computing environment designed for knowledge work. He argues that these capabilities are not mere conveniences, they are fundamental augmentations of memory, analysis, and expression. By externalizing the tasks of organizing, searching, and structuring information into a fast, interactive medium, the human user's cognitive resources are freed for higher-level activities like synthesis, creative association, and critical judgment. This section provides a powerful argument that the medium in which we work directly shapes the thoughts we can have. The proposed symbol manipulation system is a direct implementation of the H-land philosophy. A new artifact, the interactive screen, necessitates a new language, symbolic addresses, view commands, and a new methodology, nonlinear composition, dynamic exploration, requiring training to master. Section 6. The program, a strategic implementation. The final major section of the framework outlines Engelbart's proposed research program to realize his vision. The central claim of this section is that achieving augmentation requires a long-term, multifaceted, and self-referential research strategy. This is where his vision confronts the practicalities of execution. The evaluation of this section centers on the feasibility and logical structure of his proposed plan. He breaks the research down into parallel tracks. One track focuses on the advanced capability work, which involves building the most powerful augmentation system possible for a small group of researchers. This is the core of the bootstrapping engine. This group will use the very system they are developing to accelerate their own work. A second track involves short-range payoff projects, applying existing technology to specific user groups to learn more about their needs and to demonstrate the value of augmentation. A third, crucial track focuses on human system characteristics, a deep study of how users interact with the system, what skills they develop, and how their cognitive processes change. The claim here is that these tracks must be pursued concurrently and must feed into one another. Discoveries from the human system studies inform the design of the next generation advanced capability system, which in turn provides new tools for the researchers to study. The program, he outlines, is immense in its scope and ambition, a sort of Manhattan Project for the intellect. The claim's strength is its strategic coherence. It recognizes that building the future of knowledge work is not a linear engineering task but a complex process of exploration, discovery, and co-evolution. One might critique the proposal on grounds of its sheer scale and the immense resources it would demand, a scale that was perhaps difficult to appreciate for funders in the early 1960s. However, as a strategic document, its internal logic is sound. It is a plan for building a learning system, not just a set of tools, perfectly embodying the recursive, self-improving philosophy of bootstrapping that lies at the heart of the entire. For conclusion in final evaluation, Douglas Engelbart's Augmenting Human Intellect, a conceptual framework, stands as a work of extraordinary intellectual cohesion. Its internal claims build upon one another with the precision of a formal proof. From the initial proposition of a civilizational need to augment intellect, Engelbart constructs a complete, self-reinforcing system of thought. The H-land model provides a robust and holistic grammar for deconstructing and re-engineering intellectual work. The principle of bootstrapping offers a dynamic, plausible, and profoundly optimistic mechanism for achieving exponential progress. His detailed examples of hierarchical information structuring and symbol manipulation provide a tangible vision of the augmented state, transforming abstract principles into concrete functional capabilities. Finally, his proposed research program lays out a strategic, self-referential path for turning this ambitious vision into a reality. The work's enduring power resides less in any single invention and more in this totalizing, systemic perspective. Engelbart's claims, assessed on their own terms within the document, form a tightly woven logical tapestry. He provided more than a list of features for future computers. He articulated a deep philosophy of human-machine symbiosis, a conceptual framework whose core tenets on coevolution, systemic thinking, and recursive improvement established the very foundations upon which the fields of human-computer interaction and personal computing would be built. The framework is a masterclass in programmatic thinking, a document whose primary claim is that the future is something that must be designed, engineered, and bootstrapped into existence.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.